So we were doing something important, which is, and I was talking to Clara. Yes. So Clara,
Yes.
we said that the error is 2 decimals. So my measurement should also be 2 decimals. And yes, you have the right to say 2.30 centimeters.
2.30.
Yes. Why is this important? Because you're sure it's 2.3. You don't know if it's 2.31. You don't know if it's 2.32. So the last digit can fluctuate and it's no problem. But if you write 2.3, it's as if you're telling to your audience it's between 2.4 and 2.2, you know. But by saying 2.30, you're just stating that 3 is a very sure digit. You see what I mean? So if you look at the rule, which is in the next slide, which is here, every time you write an uncertainty, it has to be 1 sig fig, and it must have a unit, and the measurement must have the same number of decimals as the uncertainty on it. Okay, now back to our value, I can see my error is 1 sig fig, and I can see it has a unit. And whenever I go back to my actual measurement, I see they have the same number of decimals and therefore the same precision. Okay? Probably I confused you a bit with me signing out. Let us try to do another measurement that is analog, actually digital, and probably I can ask George to help me. So George, let us talk a bit about my neighbor. My neighbor measured his mass and it was actually 65.2 kilograms. Okay, my neighbor used a digital measuring tool. Are you with me, George?
Yes, I'm with you.
All right, so it was a digital measuring tool. So I don't need to estimate, because as you can see here, Clara was estimating 2.3 or 2.30 or 2.31. No need to estimate because I have a screen. So, and this is a bathroom scale, by the way. Can you tell me the error or the smallest measurement one can make using this scale? So it's the smallest reading. What is the smallest reading?
How am I supposed to know, like, what's the smallest subdivision if I can't actually see it? I mean, I think the balance is supposed to be accurate somehow.
Okay, so what I can tell you is, this is everything he can see on the screen. He cannot see more, he cannot see less. Can you guess now what is the smallest reading the scale can do?
Plus or minus 0.1, I think.
Exactly, because it can give you only 1 decimal. So every time you have a digital measuring tool, the rule states the error is only the smallest reading, and smallest reading means only 1 digit, the last one. And whenever you have an analog measuring tool, you have to say it is actually the smallest subdivision divided by 2. All right. Why divided by 2? Because you can estimate up to half of it. So Clara can say 2.35, and the 5 is an estimation. But here we don't need to estimate with the digital because we read everything on the screen. Now stay with me, George. How many sig figs do you have here?
Sorry, doctor, what did you ask me?
All right. How many sig figs do you have here? Only 1, right? 1 sig fig. You see where I am? So here, highlighted. So how many sig figs do I have? It's only 1. Do I have a unit? Can you hear me, George?
Yes, so kilograms.
Yes, and I can see that, let me put this away, and I can see that the error and the measurement itself, they have the same number of decimals. Okay, so no need to change anything. So it's so much easier to deal with a digital measuring tools, as you can see. Let me put the chat on. All right. Now the general rule states, I think the general rule is...
Doctor?
Yes. Yes.
Can you repeat, please, why the error 0.1 مش 0.01, please?
For the digital or analog?
Digital.
Okay. For the digital measuring tool, actually you can see that the smallest reading you can have is 0.1, isn't it? Let's say you're so tiny and you're measuring, I don't know, the mass of a spoon or the mass of a small quantity of salt. The smallest it can measure is 0.1 because it has 3 digits and 1 decimal point. This is how the screen is. And this is how the sensor works. This is how the electronics of the spring scale, the bathroom scale function. It's the measuring tool itself. So if you want a measuring tool to give you a bigger error or a smaller error, you need to throw this one and go buy another one. You see?
Okay. Yes.
Does that make more sense?
Yes. Thank you.
All right. Now I want to show you. So basically, just a reminder, we're dealing here with the instrumental error. Okay, we're discussing the uncertainty of a certain instrument. I'm going to show you 2 different rulers. You see? Both rulers, this one is in feet and this one is in inches. And you see the smallest subdivision is way different, right? So the smallest subdivision here is this, and the smallest subdivision here is this. So different rulers could have different uncertainties. And here you can see centimeters. Here you can see inches, if I'm not wrong. So also the smallest subdivision here is different than this one. And on the Lebanese market, if you go to any bookstore, you can find rulers with different precision, right? Different uncertainties. I remember when I was in high school, we had to buy a ruler that is not a regular ruler like this one. This is a regular ruler. I remember we had to buy a ruler semi-millimetre, and probably the French curriculum students understand this. I don't know if they still ask you to buy one. The 1 millimeter is even divided by 2 to increase the precision. I don't know if you have this problem now. Do you have to buy a semi-millimetre ruler nowadays or not anymore?
No.
Why?
No.
Why? Probably you found better tools like digital sensors to use. I graduated in 1997, probably before you were born.
We used البابيه مليمتريه تبع اللي بنرسم عليها الجرافيك.
But the smallest subdivision is 1 millimeter, not less.
Yes.
Okay. So imagine I had to buy a ruler, the smallest subdivision of which is 0.5 millimeter. So the error is half of it, you know? Crazy. Do you think you can tell me? So probably I can ask, let me see, Mia, a quick review. Is that a digital measuring tool or analog measuring tool? This one.
Analog.
And this one.
Digital.
And this one. It's a thermometer.
Analog.
All right. The rule for the analog, you take the smallest subdivision divided by 2. The rule for the digital, you just take the smallest subdivision. Do you think you can do this on your own, write the measurement and the uncertainty? Shall I give you a week to think about it and we can discuss the answers next time? Yeah, take a screenshot of this one. I'm going to send it to you, but probably you're in a hurry and you want to do it now. I think we can summarize quickly uncertainties, make sure it's 1 sig fig, make sure you add the unit, and make sure the same number of decimals for the measurement and for the uncertainty. Now I'm ready to go for averages, okay? Averages. Probably ask Mia to stay with me. Mia, this guy, I don't know if you know him, measured his mass many times. Question number 1, why do you believe he actually need to measure the mass many times? Why 3 trials?
In order to increase accuracy.
All right, accuracy or precision, what's the difference?
Nسيت.
All right, probably
Bala, accuracy is when the number you get is really close to the true number.
Yes.
Precision is when the values are close to each other.
All right, so probably this bathroom scale is wrong, and it's gonna give you many trials that are very close to each other. Finding the average will never tell you the true value. So probably to increase precision, I would say. All right, but it doesn't matter at the moment. Before we do the average, make sure that all the trials are basically done at the same time, same conditions. For us to do an average, the same experiment has to be done. No changes whatsoever, okay? So Mia was doing the thing. How do you find the average, Mia?
We add them and we divide by 3.
Okay, so we follow this equation. Sigma xi means add all the measurements, divided by n means divide by the number of measurements. We can call it x bar or m bar. Bar means average. Okay, so we know how to do the average. Can you tell me, I suppose you have a calculator, can you tell me the answer for m bar? Probably 89. Point
89.3.
And the unit is kilograms. How many decimals should I add? I don't know yet. Now we need to find the error on the average. My IB students actually are required to find the range, and the range is the difference between the highest value and the lowest value. This is the highest, this is the lowest, divided by 2. This is an approximated way to find the uncertainty, but us, we're gonna do the RMS value. All right. In chemistry lab at LAU, probably you're going to do the standard deviation. RMS and standard deviation are actually very close ideas. For us, it doesn't matter. This is how we do the RMS. All right. Probably you saw this one before. So N is a number of measurement. What is sigma DI? Sigma DI is actually, by the way, this is sigma DI squared. It means I need to do D1 squared plus D2 squared plus D3 squared and so on. Now the question is, what is D1? Anybody has an idea how to do standard deviation or RMS? What does D1 stand for? You don't.
Isn't it x minus x bar? يعني x1 minus x bar.
Yeah, it is the
it's the absolute value.
Yeah, it is the deviation. So in this case, D1 is M1 minus M bar, or in other words, how far away each measurement is from the average. All right. It's called the deviation. We don't care about absolute value or not, because eventually I'm going to do the square of it. So it's going to be positive. So I'm going to do the deviation for each and then square them all up and eventually add them all. So I'm going to do this and divide by n into n minus 1. And don't forget to do the whole thing rooted and make sure it's 1 sig fig for the alpha. So you need to round it, make sure it has a unit, and make sure to fix the number of decimals. Shall I give you a few minutes to do the error? Let me take a screenshot of this one to stay with us, and let me put it on this slide. So what I need you to do, try to find the RMS value, okay? And this is the RMS for us. So you can keep it in front of you. I'm gonna be quiet for a minute. And you can do mistakes. And give me as many sig figs as you want. We can round it together. Yes, you can answer in the chat. All right, so far Gael and Naya, they have very close answers, similar answers. I can see Mia as well. I'm gonna write 0.2, 1 sig fig. I will add kilograms, and then I will look at decimals. That's 1 decimal. The average is 1 decimal. So we're fine with those answers, okay? So rule number 1 or step number 1, round your RMS to 1 sig fig. Step number 2, make sure the unit is the same for RMS and average. Step number 3 is to make sure they have the same number of decimals. Otherwise, round your average or add zeros to your average, okay? Because the RMS is the one who dictates how precise the average should be, all right? I know that this is time consuming. As you can see, I gave you a minute or 2 to finish the RMS. Please don't you ever use this equation anymore. It's time consuming. I just wanted you to know it existed. I wanted you to know what it means and how to deal with it, but I'm not willing to waste your time and make you use it. However, I prepared a YouTube video done on my own calculator on how to plug in the values, use the statistical option you have on your calculator, and find the RMS in one click. You only need to round your answer because the calculator does not know how to round it for you. Please watch the video. We can watch it now, but I don't want to waste your time. However, the video was done on a regular Casio calculator. If you believe your calculator is different, please, I urge you to let me know so I can teach you how you can do it on your own. Learn how to do it on your own calculator, okay? Because the other values have 1 decimal. Okay, why 1 sig fig? So Naya, the uncertainty is always 1 sig fig. And by the way, your question is very important. Let me tell you. Let's say the mass is 58.23, all right? And I say it's plus or minus 0.12. Okay, when I say it's 0.12, what does it mean? It means that since I have a 2, so this is fluctuating. Let me change the pen. I need a bigger pen. Okay. So what does it mean? Let's focus on the 1. You see this 1? This is a digit that says that this number is fluctuating. It also says that this one is very precise to keep. So you know your answer is 58 for sure, and you are allowed only 1 fluctuating digit, which is the 2, all right? Whenever this tells me that this is an estimation, everything behind the 2 and behind the 1, they don't make sense anymore. Imagine your salary is 52. All right, I'm confused now. $52.3 salary for a period, not for a month or for a day, plus or minus 0.1. All right, it means that you will actually have 52 for sure, but this one could fluctuate due to many reasons. It could be a 4 or a 2. So I'm sure about the 52, but I cannot say your salary is 52.36 because anyway, the 3 I'm not sure about. How can I be sure about extra digits? So it makes no sense to give an error that has more than 1 digit. All right, so your error has to be only 1 significant figure because it tells you this digit I'm not sure about, meaning all the other digits on your right will make no sense whatsoever. So Naya, did I make sense out of my answer? All right. Naya, I know this is not very clear to you, but I'm sure it's gonna get clearer with more examples, okay? All right, so now just ignore the scratch work I did on this slide. So let me just put an X because I don't want you to take a screenshot on this one. Do you think you can find the average of those temperatures and find the RMS if I give you a week to think about it? So this is another assignment you can do over the week. It's not graded. It's also optional, but please, let's say it's not optional. I want you to do it even though it's not graded, and we can share the answers later. All right, we're done with averages, and please, to do this assignment, watch the video and try it on your calculator, not using the equation, so you can give yourself a chance to do this trial, okay? Now calculated value. So we need to calculate the force. We are given the acceleration. We are given the mass. Who found the acceleration? I don't know. Probably one of your friends did the measurement using an analog or a digital measuring tool. I have no idea. The friend gave me the value and the error on the value. So this is the value and this is the uncertainty. And I can see units. I can see uncertainty 1 sig fig. I can see number of decimal matching. Everything looks perfectly well. I look at the mass. Somebody, is there a way to find the RMS on the calculator? Yes, watch the video, Naya. Okay, I gave you the link. If you have time, we can watch it together. I simply don't want to wait for 2 minutes and you watch on my screen. All right. Although it's a good idea to watch it together, probably pause and answer your questions. All right. And then my neighbor probably measured the mass using some measuring tool I have no idea about. And he gave me the error as well. I have no idea how they did the measurements. Okay. They match. Everything is perfect. My job is to calculate F. Probably I can ask Gael to help me with that. So Gael, your job is to calculate F. Can you do the calculation for F? Using this law. By the way, what do you call this law? Do you know the name of this law?
Newton's.
This is Newton the
second law.
Yeah, Newton's second law. That's so cool. Newton is my favorite. I have to tell you this. So how do you find F?
Originally, for calculate F, we do 2.2 times 15.8.
Yes.
And then for the uncertainty, there is an equation between x is equals to the radical of s of x over x exponent 2 plus s of y over y exponent 2.
All right. Can we find F first before we start the Chinese part?
Okay.
You know, this is racist because if any of the student is Chinese, probably the student will be upset. So I didn't mean any racist comment. But you know, Chinese is difficult for most of the people on the planet, or not, I don't know. So the answer is?
34.76.
Okay. We don't know how to round it yet, because we need the uncertainty. I'm going to say Newton. Now we need to find the uncertainty, and your method is very legit. However, I need to teach you a method that would work for any function. The method you stated would work for multiplication and division. Am I right? For plus and minus as well?
For plus and minus, there's another equation.
All right. What if you have radical or sine or cosine? Do you have an equation for that?
I don't know them.
All right, definitely they do exist. So I need to give you a general form on how to find the error on a calculated value. By the way, we call this error propagation of error. Why? Because we believe the error on A will propagate to F, and the error on M will also propagate through F through the function itself. So the function will dictate on how the error is going to propagate. So it's called propagation of error. It has an equation. The equation looks horrible, I know, but let me go through it and let me help you in the future to use it, okay? So this is another slide that gives you the equation. Now let me translate it into simple terms. This means, so Naya loves the equation, I suppose. This means the derivative of f with respect to x. It's a simple derivative. This is the derivative of f with respect to y. And this is the derivative of f with respect to z. And in my case, I only have two measurements. So I'm going to do only two derivatives. This is the error on x given. This is the error on y given. And I don't need this one since I have only two parameters. Now derivatives. I know since you are fresh graduates from high school, you know a lot about derivatives. I'm so proud of you. I'm going to ask someone like Giscard. I did not talk to Giscard today. Giscard, if you have a constant, what's the derivative of a constant?
0.
0. If you have constant times x, what's the derivative of the function?
Constant, the c.
All right. If you have c over x, do you remember what the derivative is? Of course you do remember. Or not. It's okay if you don't, because we're not doing math here. You can ask me. So do you remember what is the
I don't, to be honest.
Okay, which is fine. Just ask me, don't ignore it. So it's minus c over x squared. If you guys cannot remember, you ask me. So here I'm going to do the derivative of f. I'm going to take m to be my variable. I mean my x, then I'm gonna take a to be my variable, meaning my x, and everything else to be constant. Giscard, I want you to try to help me. Derivative of f, if a is my variable, so this means f prime. Let's do f prime. Look at a is your x. What will be the answer?
M.
Exactly. So this is m. Now do the derivative, but take m to be your variable, your x.
A.
Awesome. You see, I know it looks so confusing, but if we try to translate it into words, it's actually easy. So you have to put here m. This is error on a. You put here a, error on m. You have a, you have error on m. You have m, you have error on a. You plug in the value. The calculator does the work for you. Can you give me an answer? Alpha of f. Take your time. And there's no means to do this differently. I mean on a calculator or some different app. I'm waiting for an answer for error on f. Yes, I'm gonna explain again. So for the students who are doing the calculation, probably I can talk to Mia and talk to the students who do not understand. This is a general equation. If you don't like the way it's written, write it in English. Derivative times error, derivative times error, derivative times error. Here I have only two measurements, so I'm gonna do only two derivatives. All right. And by the way, it looks very similar to the Pythagorean theorem. It has squared plus squared and then radical of the whole thing. How do you do the derivative? As you can see, you have many variables. M is a variable. It is a measured value. A is also a measured value. So every derivative I do, I should take one to be my x and everything else to be a constant. Then change my x, everything else to be a constant. Then change my x, everything else to be a constant. Giscard and I, we took here a to be the variable and m to be the constant, and we did the derivative. So this looks like m times x, the derivative of which is m. Then we changed our variable to m, so it looks like x times a, the derivative of which is a, and we plug in the values. Are you still confused, Mia? I think you're still confused, and you can say that it's okay.
Like I understand, but I don't know how I would be able to think about it on my.
Okay. The solution to your problem is to do it with me. Let me be your partner and let me do it for you. Deal? All right. So Mia or anyone else, while doing the derivatives, please ask me to do it for you. Remember, this is not a math class, it's physics lab. I can do the work for you. And while doing it for you, you can learn from my method, okay? Naya has an answer. She said 1.8. Anyone else got something similar? Don't forget to do radical of your final answer. I need at least one confirmation. All right. Probably I do trust Naya's answer. Wait a bit for the others to give another answer. Just to give a chance for your friends to do the work. Naya, meanwhile, can you help me round this value to 1 sig fig? Because all uncertainties must be 1 sig fig. All right. And any unit? The unit for the error on the force. Yes, Newton. It's funny, no, and then N. So 2 newtons. Now I'm going to go back to this slide, actually this slide. I know that F is this, and the error is plus or minus 2, right? All right, how many decimal is the error? No decimal, 0 decimal. So make sure you round your F to no decimal at all. What's the answer? . 35, all right? So step number 1, make sure to round your uncertainty to 1 sig fig. Step number 2, add a unit, because sometimes the unit could be different and you will be confused. Step number 3, make sure they have the same number of decimal. I'm talking about the error and the value itself. So now we know we should round this to 35 and not 34.8. Who dictates this? The error itself. So the error will tell me how precise the value is, okay? So now for the last slide, you have an example to do on your own. You are given the function Ohm's law, U is equal to Ri. You are given U with the error. You are given I with the error. There's a conversion of units you need to do to convert to amperes. Otherwise, you will not get an SI unit. Oh, the question is find R. So the function looks a bit different. It's gonna be U over I. Okay, so find R and find the error on R. Think about it. I'm gonna give you a week. Yes, that's an assignment. I'm not gonna say it's optional. It's not optional. I want you to do it. This is super important. Otherwise, you're gonna be miserable in the midterm. And no, it's not graded. So I'm gonna definitely give you an answer sheet so you can correct yourself. Is that cool? I think that's it. Before you go, probably I can show you how your Blackboard is gonna look like. Let me show you. This is not your section, but if I show you another section, probably you can see. You will have announcements, syllabus, manual, and data analysis. The announcements are gonna stay here forever. So if you click announcement, you will have the chance to go through all the announcements throughout the semester, because sometimes you need to go back to the link or anything you want, okay? By the way, make sure you add yourself to the chat, because sometimes it's helpful for you and for me. Syllabus, under syllabus, you will see the actual syllabus as PDF, if I'm not wrong, and the PowerPoint, because sometimes it could be helpful. Under manual, you will see a PDF and a doc version. You need the doc version to extract the lab report and to type on it. The PDF version is there only because I believe it's user-friendly. You can view it from your phone. You can view it from your tablet. It's easier to see and it looks prettier, because the doc could be mixed and messed up. I don't know what Blackboard could do to it. That's why I gave you 2 versions. Read everything you want, but take only the part that you need for the lab report. مش تعطوني كل المانيوال, only the lab report. By the way, there's chapter 0, and chapter 0 is about data analysis, what we're doing now. Please read in the manual. All right, what do you expect under data analysis? The PowerPoint we just did. Assignment, which is the slides you took screenshots of. If you did not, tell me. Otherwise, wait until the evening to put them on. The recorded session that is getting recorded now, and where to submit your assignment that is not graded but is not optional as well. I want you to do it. All right, so your section is gonna look like this in the evening. Any questions before I leave you? Yes? All right. Thank you a lot for today. Please email me for any question or comment. Don't wait until next week. No need to, all right? Let's deal with your problems on the spot.
Doctor?
Yes?
Aren't there any recorded lectures?
Yes, every time I see you, I record the session. And by the way,
No, I mean like a lecture, like a pre-recorded.